What's up everyone? Welcome to part 2 of my Jupyter Notebooks tutorial series, and in this video I'm going to talk about magic functions and specifically the Timeit magic function. So for those of you who watched the first video, you saw that we used the matplotlib inline function as well as the config function. So if you want to know what options you have for magic functions, you can just open a Jupyter Notebook and type %ls magic. So when you run this, you get a list of all the line magics and all the cell magics. So line magics begin with 1% sign, and all of the code needs to be contained in a single line. And for cell magics, those begin with 2% signs, and all the code contained in a cell, when you run it, will be run using that magic function. So if you want to read more up on this, you can come to the IPython website, and they have a page for all the magic functions, gives you an explanation of how they work and what they do and all that. So I'll leave a link in the description. So the magic function I want to focus on in this video is the Timeit function. So with this magic function, we can time the execution needed for a bit of code. So for example, if I do %timeit and then do something simple like 3 plus 1, what this does is it runs that little calculation a bunch of times, and it takes the 3 best attempts and gives me the time. So you can see it did, I think, 100 million loops, and the 3 best were just under 12 nanoseconds. So you can see that this is pretty useful for timing little bits of code and trying to optimize to bring that time down. So what's nice about this is it will run for a fixed amount of time. So if you give it a bit of code that is really quick, like for example, just a few nanoseconds, it's going to be able to do a lot of loops in a short amount of time. Well, in the fixed amount of time that it's given. If you give it something a little more complicated that takes like microseconds or milliseconds, it's not going to be able to do as many loops. So that's good because it's always going to take the same amount of time to run this magic function, and you're not going to sit there and you're never going to wait 5 minutes while this thing runs 100 million times. So that's good. So for the Timeit line magic, we can also define a function and then run it with this command. So for example, let's create a function called add 2 nums. We'll take an A and B. And all it will do is return A plus B. So now let's time this thing using the same thing, 3 plus 1. So Timeit, and we'll do add 2 nums, and we'll do 3 and 1. So let's see what we get here. So pretty interesting, when we're doing the exact same bit of code, just 3 plus 1, it actually takes about almost 9 times longer when we do it in a function call. So as before, we were getting about 12. Now we're getting 90 nanoseconds. So kind of interesting. One thing to keep aware of when you're writing your code, keep the simple stuff simple. Don't overcomplicate it. So that's the line magic version. And let's just do one more example. Let's do a list comprehension. So Timeit, and we'll do A equals list, and we'll do 4 plus I for I in range 1000. So let's see how long this list comprehension takes. So 52 microseconds, and you can see we're only able to do 10,000 loops because the list comprehension takes so much longer than just a simple add. And yeah, we're doing 1,000 loops, so it's going to take about over 1,000 times longer than just a simple add. So we can also do the cell magic version of it. So let's write a cell magic that's basically going to do the same thing as our list comprehension. So we'll do %% Timeit, and then let's create an empty list called A, and for I in range 1000, let's just do A dot append, and we'll do append 4 plus I. So let's see how long this takes. So you can see the full list version, or the for loop version, is a little bit slower than the list comprehension version. The list comprehension was doing it about 52 microseconds. Here we're taking 92 microseconds. So another point to make, when you can, use list comprehensions, because in general, they're going to be faster than a for loop. So this is just a side note, but since we're talking about speed, I'd like to just mention that NumPy is a lot better at these sort of calculations, especially when we're doing addition or any sort of computation in a loop. So let's recreate the exact same calculation, but using NumPy. So first, import NumPy as NP, and then we'll do Timeit, and we'll do 4 plus np dot arrange 1000. So you can see that this is taking 2.4 microseconds, whereas before our list comprehension was taking 52 microseconds. And NumPy really shines when the number of iterations goes higher. So let's go up to 100,000. Run the list comprehension. So now we're taking 5.2 milliseconds, and if we run in NumPy, we're taking 87 microseconds. So we're getting a huge speed up with this. So the moral of the story, when you can, keep it simple. Don't overcomplicate things by putting them in functions if you don't have to, because the simple things in one line are always going to run faster. And also, list comprehensions in general are going to be faster than for loops written out. You can see here we are getting close to 2x speed up. And finally, when you can, use NumPy, especially for computation in a loop. If you can use NumPy, you're going to get a really big speed up, especially when the number of loops is high. So that's it, guys. If you had any questions or you'd like to see other magic functions described, you can leave a comment. I'll try and get to it. If you like the video, leave it a like. And if you're new and want to see more videos, hit the subscribe button. Thanks, guys. See ya.